All right, so in this lesson here, we're going to be taking a look at how do we use a right angle triangle to solve for length. Now, in the previous lesson, we were taking a look at solving for an angle. In the past, we've taken a look at Pythagorean theorem and solving for length. Now we're actually going to take a look at using our trig ratios to solve for length. Now, our trig ratios are these ones here that are on our formula page, okay, which I've given to you. And if you don't have one, make sure that you get one from me. But these are our three ratios, right? Sine theta, cos theta, and tangent theta. And we can use those to solve for an angle, but we can also use them to solve for a length. So, as I mentioned here, sometimes an angle is known, but only one side length is given. Okay, so in this case, we're gonna be using the tan function to start at least, to solve for the side length that was not given. The formula that we use is exactly the same, or our equation, but the process is different. So we're going to be using the same tan theta is equal to opposite over adjacent, but now the process that we're going to be going through is going to be a little bit different. So let's do an example here, and let's find the side of a triangle. Let's find the side length of side x. So that's right here. This is our missing side. This is the piece that we want to try to solve for. Now you'll notice here we're given this side length, and we're also given the angle, and we can consider that angle to be theta. Okay, we can consider that to be theta. That is our angle. The first thing we always need to do is, based on that angle that's given in this case here, it's not the angle that we need to find, it's the angle that's given. We want to label our triangle based on this angle right here. Long side, as always, is our hypotenuse. The side beside our angle is going to be our adjacent side, and then the other one, or the one that is not beside, is our opposite side. Now, based on this here, if we look at the information that we have, we know our angle is 56 degrees, and we also know that the adjacent is unknown, and we know the opposite side of 14 meters. Okay, so we're always going to have three pieces of information, two that we know, one that we need to try to find. So here we have an angle and we have our opposite side. We want to try to find our adjacent side. Based on this here, if we look at our formula page, now again, we're only using tangent to start. Okay, opposite and adjacent are in the tangent function, so we're going to be using our tangent function. So tan of theta is equal to opposite over adjacent. Okay, opposite over adjacent. Now, we insert our known information into our function. So tan of theta, well, now we know theta is 56 degrees, and it's equal to opposite over adjacent. Opposite is 14 meters, and adjacent is unknown. We'll call it x. Okay, so we're going to call it x. Now, what we're going to do here is we're now going to solve for our missing piece when we make this into two ratios, okay, or two matching fractions. We've done this in previous lessons, okay, so you've seen this before, but now we're trying to solve for our missing piece right here, and in this case, it's going to be a piece that is kind of by itself. It's going to be either top or bottom of the right-hand side. Now I'm just going to slide this up, and I'm going to go through the method of cross multiply and divide again, or what we may call the fish method, to try to solve for x. We set up two fractions which are equal, and if we need to put something over 1, we put it over 1, just like we did up here. Okay, so we put it over 1. Then, to solve for x, we start with the known value on the side of the missing piece. So the missing piece is here. Here's the known value, so we're going to start right here. I'm going to put a dot right there, and we're going to multiply across. So that means that because we're on top, we multiply down. So this is multiplication right here, cross multiply. Then that answer, we divide by the value on top or on the bottom, so the opposite value, and that's going to give us our value of x. So when we do this, it is going to be 14 meters times 1 divided by the tangent of 56 degrees, and that's going to equal to x. Now, in this case here, we're actually also going to be doing something a little bit new as well, and we are going to take the tan of an angle, which is going to give us the ratio. This is going to provide us that ratio of tangent, the ratio that's associated with tangent of 56. So what that would be is it would be tan 56, so that would be a ratio of 1.48. Now, I'm not going to do this separately. I'm going to do it all together, and it'll depend on your calculators too how you do this. But when I go through, I'm going to do 14 times 1 divided by tan of 56, and that's going to equal x is going to be 9.44 meters. 9.44 meters. Now, I'd really like you to try this on your calculators because there's a couple different ways of doing it. Number one, you might have to hit tan first, then 56. Or, depending on your calculator, you might have to hit 56 first and then tan. Okay, each calculator is a little bit different. We'll talk about this in class as well. But try it out. Try both ways. Which one gives you 9.44? And remember again, we always need to make sure that our calculators are in degrees. So, what we've done here is exactly just finish up our up top here. So we know that x is equal to 9.44 meters. Okay, based on the drawing, that makes about sense. 56 degrees is a bit bigger than 45 degrees. That means that the opposite side is going to be bigger. Let's do two more examples using tan. Let's find the unknown side. Well, in this case here, this is our unknown side right here. Okay, that we're looking for A, and we're given theta up here. Okay, theta is equal to 71 degrees. So I'm just going to put that on the side here. Is equal to 71 degrees. Now, 8 is right beside theta, so this is going to be the adjacent side. This is our hypotenuse, as always, and this is the opposite side. Looks very similar to what we had before. Adjacent, opposite, and hypotenuse with our angle up on top. The difference, though, is that this time we know the adjacent side. It's 8 meters, and our opposite side is our unknown, or A. Now again, we would always take a look at our formula page to figure out which ones we need. We have adjacent, we want to find opposite, so that means we are using tan. Tan involves opposite and adjacent, so we're going to use that to solve here. So tan of theta is equal to opposite over adjacent. Tan of our angle, which is theta, is 71 degrees, and that is equal to the opposite, which is A, over 8 meters. Now we put that over 1 because we are going to come up with the, we need two ratios. And now because A is on top, we actually start on the bottom with 8. And now we're going to multiply by tan of 71. So that's going to be multiply. We're then going to divide by 1. And that is going to equal to our A value. So it's going to be 8 meters times tan of 71 degrees divided by 1, and that's going to equal to whatever A is. Now we plug that in on the calculator here. We do 8 times, and now again, I do tan 71. You might have to do 71 tan, divide by 1, and A is equal to 23.23 meters. 23.23 meters. Now again, bigger value of theta, so our opposite is going to be bigger than our adjacent side right here. One more example to take a look at, and that is to determine the measure of side length XZ. All right, XZ is right here. Okay, we're looking for this side right here, which, as you can tell, is the hypotenuse. Here's our angle, theta, so that means this is our adjacent, and this is our opposite side. Now, in this type of question here, if we don't know the other trig ratios, what we're going to have to do is find adjacent and then solve for hypotenuse. So that's kind of what I'm going to be asking here. We want to find the adjacent, then we're going to find the hypotenuse. So, theta is equal to 40 degrees. Opposite is equal to 62 yards, and because we're just using tan in this case, we need to figure out what our adjacent is. Okay, Once we find the adjacent, then we can use Pythagorean theorem to find our hypotenuse. So, tangent theta is opposite over adjacent. And I should make that into more of a theta, not a q. Okay, that's a theta. So that means that tangent of 40 degrees is equal to 62 yards over our unknown. I'm just going to put a question mark there. Do what I'm going to consider to be the fish method right here. 62 yards times 1 divided by tan of 40 degrees is equal to 62 times 1 divided by tan 40, 73.89 yards. 73.89 yards, and that was rounded. All right, now we know our adjacent side. To find our hypotenuse, we're going to use Pythagorean theorem. A squared plus b squared is equal to c squared, and I'm going to call this A, B, C. 73.89 squared plus 62 squared is equal to c squared. And when we do this whole thing, I'm going to go through very quickly here. 73.89 squared plus 62 squared is equal to that. Take the square root of our answer. It is 96.46 yards. Okay, 96.46 yards, and that would be our final answer. Now again, this is based on just using tan. In the next part of this lesson, we're going to look at sine and cos, which would be a lot easier to find our hypotenuse for.